Have you heard about IEEE 802.3? It has a long history and has to do with our topic today, Ethernet. Ethernet is a communication standard that was developed in the early 80s to network computer and other devices in a local environment such as home or building. The local environment is defined as a LAN or local area network. It connects multiple devices so that they can create, store, and share information with others in the location. Ethernet is a wired system that started with using coaxial cable and has successfully progressed to now using two-state pair, copper wiring, and fiber optic wiring. Let's break. Who invented two-state pair wiring? Alexander Graham Bell invented two-state pair wiring in 1881. In 1983, Ethernet was standardized in the standard IEEE 802.3 by the Institute of Electrical and Electronic Engineering of IEEE. This standard defined the physical layer and the MAC or media access control portion of the data link layer or wired network. These two layers are defined as the first two layers in the OSI or Open System Interconnection Model. The physical layer consists of the following components: cabling and devices. First, let's take a look at the Ethernet cabling. As stated previously, Ethernet cables comes as coaxial cables, which is not very common except in older installation, two-state pair and fiber optic. The most common cable is two-state pair cables, with the latest being category 6 with speed up to 1 GB per second, and Cat 6A and Cat 7 with speeds up to 10 GB per second. Category 5 and 5E cables are both still used in many existing applications, but handle the lower speeds between 10 MB per second to 100 MB per second, but are more susceptible to noise. The Ethernet two-state pair utilizes half duplex. RJ45 8-pin connector at either end of the cables, that is pin for transmitting and receiving data in either half or full duplex mode. Half duplex transmits data into one direction at a time, while full duplex allows data to be transmitted in both directions at the same time. Full duplex in Ethernet can be achieved by using two pairs of wire to allow data to travel both directions simultaneously. However, the Ethernet devices that consist of computers, printer, or any devices with either have an internal NIC or network interface card. Let's move into the second layer of the OSM model, the data link layer. The data link layer can be split into two sections: the logical link control or LSC and the media access control or MAC. The logical link control establishes path for data on the internet to transmit between devices. The media access control uses the hardware address that are assigned to network interface card or NIC to identify a specific computer or device to show the source and destination of data transmission. Ethernet transmits data packets in the data link layer by using an algorithm called CSMA CD, or carrier sense multiple access with collision detection. CSMA CD is used as a standard for Ethernet to reduce data collision and increases successful data transmission. The algorithm first checks to see if there is traffic on the network. If it doesn't find any, it will send out the first bit of information to see if a collision will occur. If this first bit is successful, then it will send out the other bits while testing for collision. If a collision occurs, the algorithm calculates a waiting time and then start the process all over again until the full transmission is complete. This is a 5-port switch, and these ports on the front are called Ethernet ports or RJ45 ports. This is also a switch. This is Cisco enterprise level switch and costs a lot of money. They can have hundreds of ports and are used to connect computers in offices together. A switch is very similar to a hub. It is intelligent. It can actually learn the physical addresses of the devices that are connected to it, and it stores these physical addresses called MAC address in its table. So when a data packet is sent to a switch, it's only directed to the intended destination port, unlike a hub will just rebroadcast the data to every port. So as an example, if this computer here wanted to communicate with over here, the data packets arrive at the switches, and then the switch will look at its table of MAC addresses and matching ports and deliver the data to correct port, and then the data packets will only go to that computer. So that's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. A router is a computer network devices that forward the data packets towards their destination through a process known as routing. The data packets are forwarded between computer network, creating an overlay internet network. It is connected to two or more data lines from different networks. When a data packets come in on lines, the routers reads the address information in the package to determine its ultimate destination. Using information in its routing table or routing policy, it directs the packet to the next network on its journey. Well, routers perform the traffic directing function on the internet. A data packet is typically forwarded from one router to another through the network that constitutes the internetwork until it reaches its destination node. A server is a computer program or machine that accepts and processes requests generated by another program or machine and responds to them. This is the working process of a server. Let's go back to the NIC. NIC provides the physical interface between computer and cabling. It prepares data, sends data, and controls the flow of data. It can also receive and translate data into bytes for the CPU to understand. It has a specific MAC address 48-bit. Topology is the physical or logical interconnection of communicating devices, and it is divided into 4 parts that are mesh topology, star topology, bus topology, and ring topology. Here is just some example of devices, that is server, computer, laptop, phone, and tablet. Each device is connected on the network through a dedicated point-to-point link. When we say dedicated, it means that the link only carries data for the connected devices only. Each of the stations are interconnected with one another. These are the formula to calculate how many links are connected to each station. 10 links. Let's do check. Before there were 10 links connected to each station. Here we go. This is a mesh topology mostly used in home purposes like smart home automation system, military area like defense automation system, in agriculture sector like smart farm automation systems, and even more. So let's have a look why mesh topology is the right choice for Internet Things.
The Internet of Things holds great promise for helping people live well and organisations thrive. Cities, utilities and businesses worldwide are connecting sensors and devices to ensure that critical services are delivered on time, all the time. Choosing the right communication network is a key first step. Most networks today are star networks like Wi-Fi and cellular. In a star network, every device must be able to speak directly to a base station, and therefore black spots are common. Star networks are inflexible and cannot adapt to local outages or urban development. To get close to full coverage, you would need many more towers. Mesh networks are different. They're designed to be flexible and enable highly reliable connectivity even in the most challenging environments. In a mesh network, every device connects and collaborates with its neighbours. Unlike star networks, a mesh actually becomes stronger and more resilient as more devices are added. When a new device is added, it automatically checks its neighbours to find multiple reliable connections for redundancy. In the event of an outage, endpoints will automatically find an alternative path. Or if the landscape changes, the mesh automatically responds. In a mesh network, devices and sensors can speak directly to each other, improving network speed and efficiency while enabling even greater intelligence. However, not all mesh networks are created equal, and there are a range of other factors to consider. Modern advanced IP meshing verifies communications at every link in milliseconds, providing robust security and authentication to control access. For example, if a rogue device attempts to join the network, it should be identified and blocked. They must also be durable, so your assets remain connected for many years to come. They should use open standards to avoid being locked into one vendor. They should offer guaranteed service levels to ensure network uptime. The list goes on.
Alright. Besides, this mesh topology has certain disadvantages that are more number of cable I/O ports are required. It is difficult for installing and reconnecting the ports in case if one's connection missed, then we need to find the connection port and it will be difficult to identify the missing port. It requires more number of hardware to connect each link and it is expensive too. In this configuration, every commuter shares network total bus capacity. By adding more commuters, it will reduce the access speed on the network. Yet the devices share responsibility for getting data from one point to another. This terminator stops signal after reaching end of the wire to prevent signal bounce, and each commuter communicates to other commuter independently. It's referred to peer-to-peer network system. Let's talk about its advantages. It requires less cabling. Its backbone provides most efficient path. It also emits redundancy. Besides, here we have its disadvantage too. It is difficult for reconnection, it has fault isolation, and the signal reflection at the taps can cause degradation in quality. Back to star topology. Star topology is a network for local area network, a LAN, in which all nodes are individually connected to a central connection port like hub or switch. Messages are sent from network device to switch. The switch checks where the message should go and forward it to appropriate networking device. The star topology efficiently uses the transmission medium. Let's talk about its advantages. installation and configuration are easy to fault identification and to remove ports. If one computer on the network fails, the rest of the network continues to function normally. Besides, here we have its disadvantages too. More expensive. It uses a lot of cabling, which makes that the topology are very expensive. Requires more cable length. As network extended, it requires more cable length and there will be interface between computers. Single point failure. As hop being connected to every computer on the network, there will be a communication breakdown between computers when hop fails. Comparing with the bus topology, it is expensive than bus topology. It can be installed only for LAN, but bus topology can install only for a smaller network. For this comparison, star topology is good. Thank you.